In the last video we met classes in Python. These were a way to create our own data types, and we had two motivations for doing that. One was that we might want to represent data which doesn't fit very well into one of the built-in types, especially complex data containing multiple different parts. Another was that classes allow us to introduce operations specific to the data we're trying to represent, and to express those operations in a natural way which is easy to write and easy to understand. Let's begin with the Ucl Student Class, which we met at the end of the last lecture. So here it is in this first code cell. On line 1 I define a new class called Ucl Student, and the Ucl Student class has to have a method called init. Init is a special function which is called when a new Ucl student is created. It's got 4 arguments as it's defined here. One is a special argument called self, which refers to the new student being created, and then there are 3 arguments which have to be supplied by a person creating an instance of our class. Inside the init function we create 3 instance variables, which are the 3 pieces of data which make up one of our Ucl students. Those are name, the number, and the subject. The syntax inside that init function creates those instance variables, and they can be referred to afterwards in the following way. If you created a Ucl student pointed to by a variable a, let's say, then you can get the name associated to that student with a.name, the student number by a.number, and the student subject by a.subject. Our Ucl student class also has a single method called speak, and that's defined on line 8 of my class declaration. If we have a Ucl student called A, then the speak method can be executed by typing a.speak and then just a pair of brackets. That seems confusing given the way we've declared the speak function looks as if it takes a single argument, but you should think of a.speak brackets as referring to speak brackets a. So let's execute this class definition. And then we're going to do something slightly interesting. We're going to define 2 Ucl students A and B with exactly the same information. They're both called alpha, they both have student number 2020-2020, and they both study mathematics. So these things are the same student, right? Well, we'll test that on line 3. We get the output false. The reason for that is that Python doesn't yet know how to figure out if 2 Ucl students objects are really equal, unless we tell it how to do so. By default, all it does is check if they are literally the same object in the computer memory, and they're not. A and B both point to different places in the computer's memory. But we probably like it if, when 2 objects were created like this, Python could tell whether they were equal, and we could check this using our double equal sign syntax. Of course, if you wanted, you could write a function which would determine whether 2 Ucl students had the same number, the same name, and the same subject, but it would be much nicer if we could use the standard double equal sign syntax. We can do that by what's called overriding the double equals. That means telling Python how to work out when 2 objects of our class are equal. And you do this by defining a class method called __eq___, which takes 2 Ucl student inputs and returns a boolean, so true or false. Let's see how to do this. So here is the same class definition as before, except now there is a new method on line 8 called __eq__, and it takes 2 Ucl students as input, traditionally referred to as self and other, although you can use any names that you like. What __eq__ is supposed to do is take 2 Ucl student objects and return true if we want to think of those as being equal, and false if we want to think of them as being not equal. So it's entirely up to you how you define the __eq__ function. As someone designing this new class, you're completely free to implement the EQ method in any way you want, even a stupid way, so long as it returns a Boolean value. So in this class definition here, the way I've chosen to implement __EQ is that it returns the Boolean, which is true if self and other have the same name and the same number, and false otherwise. So let's run this new class definition and now try the same code which we saw before. Now when on line 3 Python sees A == B, it checks the class definition and sees that we've implemented a method called __EQ__, and it uses that to decide on the Boolean value that it's going to return. In this case, it will check whether the two students have the same name and whether they have the same number, and because they do, it'll return the value true, as you can see. So let's notice that this is not necessarily the right definition of equality, because it ignores what subject they study. If I change B here so that it studies physics, well, these students have the same name and the same number, so they will still return true when we call A equals B, even though they have different subjects. So again, you can define the __EQ__ function any way you like, even a way which is not necessarily the correct one for what you want to do with these classes. So it's up to you as a class designer to choose an appropriate definition of equality which fits with the way in which you'd like to use equality in your program. Because the syntax for defining classes in Python is quite complicated, let's try another example of defining our own class. We're going to write a class to represent column vectors of height 2. That's what we do in this code cell here. The class name is 2vector because it represents a vector of height 2. We declare it on line 1 with the keyword class, and then the name of the class 2vector, and then a colon, and then everything after that which is part of the class definition has to be indented by 4 spaces so that Python can see it's part of the class definition. The way we're going to represent our column vectors of height 2 is by giving them an x coordinate and a y coordinate. So the instance variables for our class 2 vector will just be a single number called x and a single number called y. So you remember the syntax that we used before for defining instance variables. We have to create a method called __init__, which will be called every time a new 2 vector is created, and we'll give it 3 arguments. The first one refers to the new thing being created, and the second one refers to the x coordinate, and the third one refers to the y coordinate. Those second and third arguments have to be provided by the person who's creating a vector. Inside the init function, we define self.x to be equal to x and self.y to be equal to y. So here, self.x is an instance variable and it's given the first value provided by the person creating the vector, and self.y will be an instance variable and be given the second value created by the person who's creating a new vector. You can see we've also implemented an __EQ__ method to check when 2 vectors are equal. What it does is just check whether self and other have the same x value and the same y value, in which case it will return true, and otherwise it will return false. So let's execute this and just try doing it. So in order to create a 2 vector, what I have to do is, let's call it v, and I need to use 2 vector. Then because init takes 3 arguments, I have to provide 2 arguments here, an x coordinate and a y coordinate. So let's say -1 and 1.5. That's my 2 vector v. So I've now created this vector, and if I'd like to get the instance variables from v, which are its x coordinate and its y coordinate, I have to do that with v.x and v.y. So let's print them out. v.x, which should be -1, and v.y, which should be 1.5. you can see when I run that really is what happens. So these are how we access the instance variables, which in our case are x and y coordinates for our vector. Now, if we're going to use vectors in our program, then probably we want to do some operations with those vectors. And the simplest kind of operation you could do would be to add two vectors. And of course, you could write a method for your class, or an independent function, which would add the two vectors and return a new instance of our class 2 vector with the appropriate x and y coordinates. But it would be much easier for us to write our program and for other people to understand our program if we could just use the ordinary plus to add two vectors. This is possible by overriding the plus function, and there's a special way to do this in Python, which is by defining a class method called __add__, which takes two inputs representing the two vectors which are going to be added by the plus. Let's do this in the next cell. So here is the exact same class definition that we had before, only now I've implemented a class method called __add__, taking two inputs which refer to the two things which are going to be added. What my __add__ method does is returns a new 2 vector, so created in the usual way, with its x coordinate being self.x plus other.x. In other words, it's adding together the two x coordinates from its two inputs. And similarly, it's creating this 2 vector with a y coordinate equal to the sum of the y coordinates from the other two vectors which are being added. That's the natural definition for vectors. So let's just see what would happen if I did plus on 2 vectors in my old class definition. You can see I get an error. The reason is it doesn't know how to add 2 vectors yet. Once we've run this new class definition, which implements the __add method, we're going to be able to do that. So let's run this class definition. Then in the next cell, we're going to create 2 vectors, a and b. So a is the vector whose coordinates are 1 and 1. B is the vector whose x coordinate is 2 and his y coordinate is 3. And we're then going to create a new vector c as a plus b. This time, because we have implemented an __add__ method in our class definition, there won't be an error. When Python sees two vectors being added together, it'll go to the class definition, see that there is a definition of __add__, and use that to create the new 2 vector c. On the last line, I'm going to print out c, or rather we'll print out its x coordinate and its y coordinate to check that they're what we expect they're going to be. So you can see what's happened here is that the x coordinate of c was 3 and the y coordinate of c was 4, and that's what we expect. So the x coordinate of a was 1, the x coordinate of y was 2, so the x coordinate of a plus b should be 1 plus 2, which is 3, and that really is what's happened. Equally, our 2 vector class had an overriding of the equality operator because we implemented that __eq__ function. So in the next cell I'm going to check that that works. I've defined d to be a new 2 vector whose x coordinate is 3 and whose y coordinate is 4, just like the x coordinate and y coordinate for c. And we're going to check whether d is equal to a plus b. Let's see what happens. Okay, it's worked. So when on that line 2 of that code cell we asked for d == a plus b, Python will go back to the class definition and see if there is a method __eq__, which it will then call to check whether d is equal to a plus b. So in fact that second line is equivalent to a call of __eq__ between d and a plus b. Okay, so there's one thing we can't do yet, which is to print out c. So c is a vector, it's got x coordinate 3 and y coordinate 4. When we printed it out before, we didn't actually print out c. What we did instead was print out the x coordinate of c and the y coordinate of c separately. Python knows how to print those things because they're just integers. But if you ask it to display C, which is what happens when in a code cell when the last line is always printed out, if we try this, we get something totally unhelpful. All it does is tell us what class C has, so it's something of type 2 vector, and it tells us where it's sitting in memory, which is this complicated looking thing here. That's the hexadecimal address of C in memory. Okay, well that didn't work. Well, perhaps we could try printing C. And we get the same problem. Python does not know how to display a vector. So it would be very helpful to us if it could do this, and it could do it in a natural, helpful way. If you want that to happen, what you need to do is add a special method to your 2-vector class implementing a function called __str__, taking a single 2-vector as an argument and returning a string representing that 2-vector. Here's how we do this. This code cell is exactly the same class definition as before, only now it has a new method called __str__, which takes a single argument representing a 2-vector. What it must do is to return a string, which Python will print when you call print on a 2-vector. So you can see here what the function does is return the concatenation of a bunch of strings. So there are a load of strings here combined with pluses, and what plus does for strings is just put one after the other. So what it does, it'll return a brackets, and then it will print the x-coordinate of whatever vector it's called on. So here we need the str function to turn the x-coordinate of that vector, which will be a number, into a string, because you can only concatenate strings and strings. You can't concatenate strings and integers. Then it will have a close bracket, then this \n, which starts a new line. So that's a special way in Python of asking a string to begin a new line. Then another open bracket, then the y-coordinate turned into a string, and then a close bracket. And I've just put a comment here reminding you that \n means start a new line in a Python string. Okay, so that's the only new thing in our 2-vector class. So let's run it again to redefine this 2-vector class. Then in the final code cell, we're going to have a go at printing out the sum of 2 vectors. So we created a vector A with x-coordinate 1 and y-coordinate 1, a vector B with x-coordinate 2 and y-coordinate -1. And this time we're going to make a print call to a vector, a print call whose input is a vector. And you can see that what we get this time is a nice string representation of our vector. So what we're doing here is called overriding. We've overridden the equality method, and that means that equals or double equal signs for our 2 vectors now behave in a special way appropriate to those 2 vectors. We've also overridden the plus in Python so that plus for 2 vectors behaves in a way appropriate to those vectors. All kinds of other Python operations can be overridden, such as subtraction. At the moment we can't subtract 2 vectors using a minus b. If you want to do that, you need to override __sub__, and so on. But the real purpose of this way to override certain Python functions is that it allows us to write very conveniently, to work with our new classes in a very convenient, easy to write and easy to understand way.